Okay, this one is calculating molarity using the solute moles. So a chemist prepares a solution of silver 1 perchlorate by measuring out 1.09 times 10 to the 3 micromoles of silver 1 perchlorate into a 200 milliliter volumetric flask, filling the flask to the mark with water. Calculate the concentration in moles per liter of the chemist's silver 1 perchlorate solution, and then round your answer to 3 significant figures, okay? So let's first remind ourselves that this issue of molarity is the number of moles of a substance, of the solute. That's the substance you're dissolving. So for example, if you're putting sugar into water, that's the sugar is the solute. The salt that you dissolve into water would be the solute. So it's the moles of the solute divided by the volume of the solution. The solution is everything. So for example, if you're looking at vinegar, vinegar has several different things in it, including water. It's mostly water. The whole thing together is the solution. And so we're going to do this in moles. And then this is going to be the volume. Okay, so that's just sort of an abbreviation, moles over volume, which we can use real abbreviations for it. We can put N, we'll use symbols, right? N divided by V, moles over volume. Now, typically, molarity in your textbook, they'll define it as moles divided by liters, not milliliters or microliters or deciliters, but liters. But in these ALEKS problems, you have to pay attention to the wording very carefully. What they're telling us here is they want it to be in moles per liter, okay? So what we need then is the number of moles. Now take a look at what they give us. It's 1.09 times 10 to the 3, not moles. The units are not in moles here. They're in micromoles. So you have to go back to chapter 1. Chapter 1 in the textbook will tell you that a micro is 10 to the minus 6. So this is 1.09 times 10 to the 3 times 10 to the minus 6 moles, right? This is a mixed problem. There's a exponent, 10 to the 3, that's scientific notation, but there's also a prefix, the micro. Now remember, if you're multiplying powers of 10 together, you add the exponents. So this would be 1.09 times 10 to the minus 3 moles, right? 3 plus a negative 6 is negative 3. So now you got the moles. Then you come down and you look at the volume. The volume, they tell you, is 200 milliliters. The point is there to tell us that both of those zeros are significant. Without the point, we wouldn't know how many sig figs this number, this measurement has. But if you have a trailing zero and there is a decimal point, it counts as a significant figure. So there's 3 sig figs. Now notice they want it in moles per liter. You have to read very carefully the question. Calculate the concentration in moles per liter, not moles per milliliter, not micromoles per milliliter, moles per liter. So we've got to convert milliliters to liters. Now there's a couple ways to do that. Milli is 10 to the minus 3. So this would be 200 dot, or point, times 10 to the minus 3. That's milliliters. Now it's in liters. So now we have the volume in liters, and we also have the number of moles in the unit of moles. So our molarity, sometimes we use a capital M to represent molarity, is going to be 1.09 times 10 to the minus 3 moles divided by 200 times 10 to the minus 3 liters. Now, it's nice when you see a problem that's easy this way. 10 to the minus 3 just happened to be the same in both the numerator and the denominator, so that simplifies it to 1.09 over 200 moles per liter. So let's just do that calculation. Well, if it were 1.09 divided by 100, it'd be 0.0109. So it's really just 0.0109 over 2, but I'll go ahead and put it in here. 1.09 divided by 200, and you get 5.45 times 10 to the minus 3. Let's convert it to scientific notation. To the left is positive, to the right is negative. 1, 2, 3. We went to the right, so that's negative. Negative 3. And you can put moles per liter, or you could put a capital M for molarity, but typically I would recommend putting that right there. Okay? So there's that one. Now, if I can, I'd like to show you another example. Let me move this one up here. Oops. Actually, let me just do this. Done. And what I'm going to do here is I'm just going to create another document just to make this a little easier. There we go. Now this one is a very similar problem. A chemist prepares a solution of silver 1 perchlorate, 1.0, oh, sorry, wrong one. My apologies. Here, let's try this one. Here we go. A chemist prepares a solution of calcium bromide, CaBr2, by measuring 1.4 times 10 to the 2 micromoles of calcium bromide into 250 ml volumetric flask, filling the flask to the mark with the water. A volumetric flask looks something like this. It has a long stem, it's called a stem, and then it has a region where you fill the liquid. And it usually has a ring here to indicate the volume. So if you fill it up with water or any solution, you fill it right up to the ring. And if you fill up right up to the ring, that's going to give you the volume that is indicated, which in this particular case is 250 ml. That's the volume, the amount of space that's in that container. Now, they tell us the volume, but they also tell us the solute. The solute is calcium bromide. It's a salt. It dissolves in water. So this solution in here has calcium bromide dissolved. Remember, when you dissolve substances, it turns into ions, when you dissolve ionic compounds. So those ions are going to be dissolved in the water. Okay? 1.4 times 10 to the 2 micromoles. That's the number of moles of the solute divided by the volume, 250 ml. But in this particular example, they want the concentration to be in micromoles per liter. They don't want it to be in moles per liter. They don't say molarity, right? They don't call it molarity. They want concentration. And the reason they don't call it molarity is per liter. It's moles per liter, I'm sorry. But they want micromoles. So if they want micromoles, leave this the same. Don't change that number. Keep that the same. You just need to change this one down here in the denominator to liters. So 250 ml and millis 10 to the minus 3. So that's 250 point. Again, that's 3 sig figs minus 3 liters. So there's your volume. So now we can do this concentration in the units they want. 1.4 times 10 to the 2 micromoles, sorry, that's micro, divided by 250 times 10 to the minus 3 liters. Now, I see all these, like, powers of 10 in there. Let's clean it up a little bit. You don't have to do it this way, but I'm going to do it anyways. If you are dividing powers of 10, such as 10 to the x divided by 10 to the y, it's 10 to the x minus y. So this would be 1.4 over 250, and then times 10. 2 minus a minus 3 is the same as 2 plus 3, that's 5. And then that would be in the units of micromoles per liter, right? 2 minus a minus 3 is 2 plus 3, which is 5. So all we got to do is 1.4 over 250. And you get 0.0056. Makes sense, right? Now, let's put it into scientific notation. Left is positive, right is negative. Left is positive. 1, 2, 3. We're moving it to the right, so this goes down by 3. So it's 5.6 times 10 to the 2 micromoles per liter. Now, in general, when you have numbers that are in the tens or hundreds, you usually don't have to use the scientific notation. So 5.6 times 10 to the 2 micromoles per liter, 10 to the 2 is 100. So this is really 5.6 times 100, which is 560. How many sig figs do we have, though? This one has 3. The original moles only has 2. So doing it as 560 is complicated. I mean, it's ambiguous. How many sig figs do we have? If you put a dot here, if you put the decimal point there, that would mean it's 3 sig figs. If you take it off, it could mean 2 or it could mean 3. So it's probably best just to leave this in scientific notation. 5.6 times 10 to the 2 micromoles per liter. I have seen in this problem cases where they want it in micromoles, but you might have millimoles in the problem. So for that type of situation, go from millimoles to moles, and then go from moles to micromoles, right? You just do your it's called prefix reassignment. So you can find examples of that if you look in the folder on YouTube, I've made a couple of videos on how to do those sort of reframing of prefixes from chapter 1. Look for the folder for chapter 1, and you'll see some discussion on that.